Assalamualaikum warahmatullahi wabarakatuh. So in this video, I will be giving you an example. So example 6.12 here is basically covers the problems related to finding the distance between 2 points, finding the midpoint M where the distance is equal between AM and BM, and the last one is finding the point M such that it divides the line segment into a ratio. So I'm going to start off by sketching or visualizing the coordinates given in this question. So this is coordinates for A and B. So A and B are the endpoints of a line. So here I'm sketching the axis. Okay, the line doesn't look nice. Okay, okay, so negative 6 and 10 could be somewhere here. I'm just ignoring the scale. This is just, sketching. This is just a rough sketch. And this is 8, negative 2. 8, negative 2 might be somewhere here. Okay. And so we are going to connect these two dots, these 2 points. So I've got a straight line where A and B are the endpoints of a line. So this is point A, this is point B. Okay. Now find the distance between these 2 points. Now the first question is not too difficult to answer, and it is actually very easy to remember the formula. So the distance between 2 points is just the square root of x2 minus x1 square plus y2 minus y1 square. So this can be your x1 and y1. This could be your x2 and your y2. So just plug in those values. So x2 minus x1, 8 minus 6 will be 8 plus 6 square plus y2 minus y1, negative 2 minus 10 square. And this is equal to 14 square plus negative 12 square. And this is just 14 square is 196, and this one is 144. Add those two together, that will become the square root of 340, and this is roughly 18.439. Okay, now this is for question A. Now if we look at the next question, question B, what is the midpoint of the line segment where M here divides the distance equally between, so that it becomes 2 equal parts? So for question B, you are looking to find the coordinate of x and y for point M. So this is for point M. You are looking to find what is x and what is y. And again, the formula is not too difficult to remember. It is just x1 plus x2 over 2 in order to find what x is. And this one is y1 plus y2 over 2. So I'm just going to plug in the values. So x1 is negative 6 plus 8 over 2. y1 is 10. 10 plus negative 2 will be 10 minus 2 over 2. And this becomes 2 over 2 8 over 2, and the final answer is 1 and 4. So this is the midpoint at coordinate 1 and 4. You have point M, where the distance is equal between AM and BM. Okay, now we are going to answer the last question, and I'm just going to erase the answers to A and B here. So in order to answer the last question, I prefer to illustrate that using a graph, and I'm not going to use a formula. I'm just going to explain it like what I've done in the previous videos. So based on this, this is an important statement where the distance of AM over MB is in this ratio 3 over 2. So based on this, you can see that this distance is slightly longer than MB. Okay, AM is slightly longer than MB based on this ratio here. So I can imagine that point M may be somewhere here. Okay, so maybe somewhere here where you don't know the value of X and Y, but you can see that this is your X and this is your Y. Okay, so next, what I can do is I can insert a right angle triangle. So let's create a right angle triangle that corresponds to the distance AM. So this is the distance AM and this is the right angle triangle. I'm going to name this side as A for AM, and this side here is B for AM. And similarly, I can construct another right angle triangle with respect to MB. So here is another right angle triangle with respect to distance MB, and I'm going to call this as A for MB, and this line over here is B for MB. And because of this statement, I can say that the length of AAM over the length of AMB must also be in this similar ratio. So I'm going to write down the statement here. The length for AAM over the length for AMB must also be 3 over 2, the ratio of that. Okay. So next, I can rearrange this equation, and it will become AAM times 2 is equal to AMB times 3. So what is AAM? So if you look at this length, this is what you're looking to find, the length of AAM. It can be obtained by having X. So this is the length of AAM. So it can be obtained by having X minus negative 6. So X minus negative 6 will be X plus 6. Next, for A and B, the length for A and B. So this is A and B. So this one can be obtained by having 8 minus X. So this length. So A and B is 8 minus X. 8 minus x times 3. Next, we're just going to solve x. That will be 2x plus 12 is equal to 24 minus 3x. 5x is equal to 24 minus 12. So 5x is just 12 and x will be 12 over 5. Okay. Next, we are going to find the value of y. So in a similar manner, I can say that the length of b for AM over the length of b for MB here must follow the ratio of 3 over 2. So b for AM over b for MB must be 3 over 2. And so this is the same as having b for AM times 2 is equal to b for MB times 3. So what is the length of BAM? So the length of BAM, as you can see it is equal to 10 minus y. Okay, the distance here is 10 minus y. Okay, 10 minus y. So I'm going to write down the answer here, 10 minus y times 2. And the length of BMB, so this is BMB. So this is the length, can be obtained by having y minus negative 2. So this is the endpoint here. So y minus negative 2 will give you the length of BMB. So y minus negative 2 becomes y plus 2. Next, we're going to solve for y. So that becomes 20 minus 2y. This is 3y plus 6. Now, next what we can have is I have 3y plus 2y. Okay, 3y plus 2y is equal to 20 minus 6. 5y is equal to 14. Y is just 14 over 5. Okay, so the point M that divides the line segment into this ratio, so the point M is at x 12 over 5 and y 14 over 5. Alright, that's all for today. Thank you very much for watching. I'll see you in the next video.